welcome back to my channel RV's Learning Point. Today we are going to learn the remaining concepts of acids, bases and salts, that is salts. So salts are obtained by the reaction of acids with bases, that is acid plus base gives salt plus water. So acid plus base gives salt plus water. Now this reaction is generally called neutralization reaction. This is called neutralization reaction. So acid plus base gives salt plus water. Now this is how salts are obtained. The cation is derived from the base. The cation is derived from the base and the anion is derived from the acid. Next, let us learn about the common salt. Common salt. So the main chemical present in the common salt is sodium chloride, NaCl. So sodium chloride. Now this sodium chloride is also obtained by the neutralization reaction. See, neutralization reaction, acid plus base gives salt plus water. Now this is a salt. This is obtained by the reaction of hydrochloric acid, that is an acid, plus sodium hydroxide, that is a base, gives NaCl, sodium chloride plus water. Now this is a neutralization reaction and this is also a displacement reaction because chlorine is being substituted in the place of OH, that is hydroxide. Now H, 2H, so H2 and you have one O remaining, that is water, and NaCl is the salt that is obtained from this neutralization reaction. Now this is how common salt is obtained and this is present in large numbers, that is in large deposits called rock salt, that is obtained from the sea. So sea has large deposits of common salt. Now let us learn the common uses of this salt. Firstly, we use common salt for cooking. We also use common salt as a preservative. And common salt is also used to separate and to get sodium metal and chlorine gas by a process called electrolysis. So these are the uses of common salt, that is used for cooking, used as a preservative and also to separate and to obtain sodium and in the form of a metal and chlorine gas by a process called electrolysis, where sodium chloride is being divided into sodium and chlorine. Next, manufacture of NaOH, that is sodium hydroxide. Now, sodium hydroxide is one of the most important alkali. Alkali is something that is base dissolved in water is called alkali. Now, this is one of the most important alkali and it is formed, that is it is made commercially by the electrolysis of saturated brine solution. Now this is made commercially by the electrolysis of saturated brine solution. Now saturated brine solution is nothing else but sodium chloride. So this process is called, that is the electrolysis of NaCl is called chloralkali process. Chloralkali process. This is called the chloralkali process. Now this has got its name chlor for chlorine, and alkali for sodium hydroxide. Now that is why chlor-alkali process. Now the equation for this process is 2NaCl plus 2H2O gives 2NaOH plus H2 gas plus chlorine gas. Now 2 sodium chloride plus 2 water molecules gives 2 NaOH, that is sodium hydroxide, plus hydrogen in its gaseous form and chlorine also in its gaseous form. Now this is very important for your board exam. So this is manufacture of sodium hydroxide. This is commercially made by the electrolysis of saturated brine solution, that is sodium chloride, and this process is called chlor-alkali process. So our next topic is washing soda. Now its chemical formula is Na2CO3 into, this dot is into 10H2O. That now this is read as sodium carbonate decahydrate. Sodium carbonate decahydrate. Now this means that 1 mole of sodium carbonate contains 10 moles of water of crystallization. Washing soda, its chemical formula is Na2CO3 into, this dot is into 10H2O. Sodium carbonate decahydrate. That means 1 mole of sodium carbonate contains 10 moles of water of crystallization. Now, the anhydrous form of sodium carbonate is called sodium carbonate in its anhydrous form. So anhydrous form is called soda ash. Soda ash. And this soda ash is dissolved in water to get washing soda. That is, the equation is Na2CO3 plus 10H2O gives Na2CO3 into 10H2O. Simple. Next, uses of sodium carbonate. This is used in the manufacture of soap, glass, paper, and also in the manufacture of some sodium compounds. Some sodium compounds like borax, caustic soda. Now, this is used as a cleansing agent in domestic purposes. It is also used in laundries, in the softening of hard water, not hot water, it is hard water. Next, baking soda. Now chemically this is sodium hydrogen carbonate. Sodium hydrogen carbonate. That is sodium hydrogen carbonate. That is NaHCO3. Now this is prepared by passing carbon dioxide. This is prepared by passing carbon dioxide in an aqueous solution of sodium carbonate. That is carbon dioxide is passed through an aqueous solution. Aqueous solution, that is, this is immersed in liquid. So 2Na2CO3, that is 2 times of sodium carbonate plus carbon dioxide plus water, as this is already present in water. Now plus water gives 2 of NaHCO3. Now this is baking soda. Now let us learn the uses of baking soda. So this is used as an antacid, that is a medicine, under the name soda bicarbonate. Now this is used to neutralize, excess acid, also called hyperacidity. Next, baking soda is used as an ingredient in baking powder. Where baking soda is added along with tartaric acid. Baking soda is added along with tartaric acid. Now, when baking soda is heated, it decomposes to form sodium carbonate and carbon dioxide. Now, tartaric acid, this is added to remove the bitter taste. Due to the formation of Na2CO3 and carbon dioxide. Carbon dioxide is added. Now carbon dioxide leads to the rise of bread and cake. Carbon dioxide leads in the rise of bread and cake, whereas tartaric acid is added to remove the bitter taste caused due to the formation of Na2CO3 with the decomposition of baking soda. Next, bleaching powder. Now chemically it is called calcium oxychloride. Its formula is CaOCl2. Now this is manufactured by Hasenclever's plant, that is by the reaction of dry slake lime on chlorine gas. Now the equation is CaOH taken twice. Now this is slake lime plus chlorine gas gives CaOCl2 plus H2O. Slake lime plus chlorine gas gives CaOCl2, that is bleaching powder, plus water. Now let us learn the uses of calcium oxychloride, that is bleaching powder. It is used for bleaching cotton and linen in textile industries. It is used in many chemical industries as an oxidizing agent. It is used as an oxidizing agent in many chemical industries, and it is also used for disinfecting drinking water and making them free of germs or microorganisms. It makes wool unshrinkable. Now these are the uses of calcium oxychloride. Next, let's learn about plaster of Paris. Now chemically it is called as calcium sulfate hemihydrate. Now this is its formula. So this is called as plaster of Paris because it is obtained from gypsum. It is obtained from gypsum, which is mainly found in Paris. So that is why it is called as plaster of Paris. Now gypsum is CaSO4, calcium sulfate, into two molecules of water. Now gypsum is heated at 373 Kelvin in a kiln. So when gypsum is heated, that is CaSO4 into 2H2O gives, when it is heated at 373 Kelvin, it gives CaSO4 into half, that is hemihydrate plus H2O. Now this is gypsum and this is plaster of Paris, POP. Uses of plaster of Paris. Now you already know that it is used for plastering fractured bones or dislocated bones so as to set them in right place. So the first use, used for plastering fractured or dislocated bones. Fractured or dislocated bones. Now, it is also used in the manufacturing of toys and decorative materials. It is also used in the manufacture of blackboard chalks. So that's it for today's video. I hope you all liked this, and if you did, then like, share and subscribe to my channel RV's Learning Point.